We've talked about graphing quadratics in vertex form. Now we're going to talk about another form of quadratics called intercept form. And in intercept form, you are going to be able to figure out the 2x-intercepts or 1x-intercept right away from the information that was given to us. So the form is here, y equals a, and a does the same thing as it's done in the other on the other functions and the other forms, but we have this x minus p times x minus q. What this means is that one x-intercept will be p comma 0, and the other one will be q comma 0. So you take the opposite of what you would see, because that minus sign will make it change. Now we have to talk about how to get the axis of symmetry and the vertex. The axis of symmetry will be exactly in between, or halfway in between, the two x-intercepts. Because if we have our two x-intercepts here, half the distance from one and half the distance from the other, that will get you at the middle, because our parabolas are symmetrical. So you will need to know the x-coordinate of the vertex is halfway between the x-intercepts. You could use the formula p plus q over 2. That will give you the x-coordinate of it. I find that most students will just plot the two x-intercepts and then find that in between. Well, once you find the axis of symmetry, that's also the x-coordinate of the vertex. So to get the y-coordinate of the vertex, you can plug in your axis of symmetry. Plugging in. Okay. So then that would give us a third point, because we have our two x-intercepts, we have the vertex, and then you want to pick another number, preferably a small number and a number easy to work with, to find out another point on our parabola, and then we're going to reflect that. So let x equal different values, substitute that number into the equation, and then you're going to reflect this point across the axis of symmetry. And again, the graph opens up and has a min if a is positive, or it opens downwards, and that means it has a max if a is negative. We don't need those areas. It's positive or negative. So let's look at this problem here. First thing I want to do is find out our x-intercepts. So it's going to be the opposite of this minus or negative 1. So it's going to be it's going to be 1 comma 0. And then here we see x minus 5 is going to be 5 comma 0. So there are the x-intercepts. Now to find your axis of symmetry, we want to go halfway in between. So 1, 2, 3, 4. Halfway in between is right here. This is our axis of symmetry at x equals 3. And again, you could have done 1 plus 5 over 2, and that still would have given you 3. Now we need to take that 3 and plug it into our original function. So you could do this in your head, or you could do it in the calculator, or you could write it out. You get y equals positive 8. So the y-coordinate of the vertex is 8. The x-coordinate was 3, so our vertex will be at 3 comma 8. Okay. So we can write that down here. 3, 8. Axis symmetry was x equals 3. This has a maximum value at y equals 8. We saw that up here. Now, to figure out that other point, I said pick an easy point. And once you have these 3 points drawn, then it becomes easier to figure out. Like, we don't want to pick x equals 0 because you may think that's an easy point to figure out, but if you follow the curve of this graph, it's going to be way down here. The y value would be. So what I would do is I would pick a point in this area, an x value in this area between your vertex and your x-intercept. So I'm going to pick x equals 2. So x equals 2. And then plug that in. 2 minus 1 times 2 minus 5. Okay, so let me fix that. Y equals negative 2 times 2 minus 1 is 1. 2 minus 3 is negative 3. So we get positive 6. 1, 2, 3, 4, 5, 6. There we go. And then we can reflect that over the axis of symmetry. So this point is 1 unit away from the axis of symmetry. We can go 1 unit on the other side, and there would be our point. So then here is our parabola. And now we can answer the domain, range, and end behavior. Domain is always going to be negative infinity, comma infinity for these quadratic functions. Range, our y value, our parabola is open downward, so that means the smallest y value is negative infinity, and the largest one will be our y coordinate of the vertex. In this case, it is 8. So range negative infinity, comma 8. And behavior, as x approaches negative infinity, y is also approaching negative infinity. And as x approaches infinity, y is approaching negative infinity because our parabola is opened downward. So graphing in intercept form is not as difficult as vertex form. There's not as much math as you're doing, but you do need to make sure you have 5 points. Now, on the next page here, we're going to graph this one. Your x-intercepts, negative 3, comma 0, because it's the opposite, and negative 5, comma 0. So then the x-coordinate of your vertex is going to be exactly in the middle. Here's our axis of symmetry at x equals negative 4. And then we're going to plug that into our equation here. So y equals 3 times negative 4 plus 3 times negative 4 plus 5. And if we type that into the calculator, that is going to give us, let's see, 3, negative 1. That will give us negative 3. So here is our vertex. So negative 4, comma negative 3. We also can see from our graph that that is going to be a minimum value right here. So it's a minimum, is at y equals negative 3. Now we need that other point. And I said last time, pick a point between your x-intercept and your vertex. Oh, we don't have a nice number in this area. So let's just go one outside. Let's go at x equals negative 2. Let's do x equals negative 2. So y equals 3. Negative 2 plus 3 times negative 2 plus 5. And I'll type I'll throw this one into the calculator so you can see how that is done. So 3 parentheses, -2 plus 3, and -2 plus 5. And we get 9. So 1, 2, 3, 4, 5, 6, 7, 8. It'll be up here. And then we reflect that over. We're 2 away from the axis of symmetry, so we get 2 over. It would be there. Now that we have our graph domain, since this graph is opened upwards, we are going to start with the smallest y value, which is -3. We go all the way to infinity. And with the end behavior, as x approaches -infinity, the y values are going up. As x approaches positive infinity, the y values are going up as well. So again, these problems are a little bit quicker to do once you get those points down. All right, this next one, I'm going to have you guys try after we talk about the x-intercepts. Is this one? This would be 4, 0, no problem. But what about this right here, this -x? Well, let's just look at the x. It would not make sense to write this x minus 0, because anything minus 0 is just what we started with. 5 minus 0 is 5. 12 minus 0 is 12. X minus 0 is just x. So when you see just an x out front, that means one of your intercepts is 0, 0. That negative that negative attached to it, that means your a value is -1. Okay, so now that I have given you the x-intercepts, pause the video, try this problem, and then we'll talk about it once you're done, and you can check your work. All right, here you go. You can look at your answers. So for this one, I picked x equals 1 for my other point and then reflected that over. Again, you could have picked other points. I try to keep the points I pick as close to the axis of symmetry or the vertex as I can. So that's why I went with that value there. Okay. So I hope that you got most of these or all of this correct, or if you didn't, you can see where you've made that mistake. So with this problem, again, we have some of the same information. We're going to graph this, figure out the vertex, but we're also going to look at this in context and say, what does this really mean in the sense of the problem? What makes sense and what doesn't make sense. And we're going to save a little bit of time in this problem by not picking another point. Okay, 1, 2, 3, 4, 5. There we go. And then the axis of symmetry will be halfway in between. So 1, 2, 3, 4, 5, 6, 7. So we need to go 3.5. 1, 2, 3.5. So here is our axis of symmetry at 1.5. Okay. So now in my calculator, I'm going to type in -0.5 times 1.5 plus 2 and 1.5 minus 5. Then we get 6.125. Okay, so 1, 2, 3, 4, 5, 6, and a little bit more than that. All right, so let's x equals 1.5. Vertex was 1.5 comma 6.125. We have a maximum of y equals 6.125. Now, looking at the other parts here, it says in context, because we said, oh, domain is going to be all real numbers, or negative comma infinity. In a non-story problem, that would be true, but we are in the middle of a diving board problem, so we got to think about what makes sense. T is representative of our time, so it would not make sense to have negative time. So that means our domain will be 0, comma, and it wouldn't make sense to have infinite time, because eventually we do hit the water. We hit the water right here at 5 seconds. So our domain is 0, comma 5. That's a duration that we are in the air. The range in context, well, we eventually hit the water and our height is 0. And we reached a maximum height of 6.125 feet. So the range, when it comes to the height above the water, we have 0 all the way to 6.125 yards in the air. So you do need to realize that in context, you need to think about, does this make sense? Why and why not? How high above the water did we jump? Well, we reached a max height of 6.125 yards, so 6.125 yards. What do the x-intercepts mean in the context of the problem? Well, the x-intercepts means that you are in the water when you've landed in the water. How tall is the diving board? So think about it. When no time has passed, you should be on that diving board because you haven't jumped at all. So how tall is the diving board? That means we need to figure out the y-intercept. We can say, okay, x is equal to 0. And we plug in 0 to our equation up here. Negative 0.5 times 0 plus 2 times 0 minus 5. And again, we can type that into our calculator, or you can do it in your head. You will get 5 yards. So what happens, and I'm going to plot this here to show you what happens in the problem. We start here on the diving board. Okay, and it's 5 yards above the pool, or above the water. We jump up, we hit our vertex, and then we come down, and right here we hit the water. And we're saying, well, what about this x-intercept here? Well, the x values on this side of our graph are all negative. It wouldn't make sense to say, oh, 2 seconds ago I was in the water. That doesn't make sense in the context of this problem. So again, just make sure you're thinking about what is practical when it comes to these word problems. For this problem here, we have a football that's being kicked, and it is modeled by this function right here. And we need to figure out how far is the football kicked. X is a horizontal distance in yards, and y is the corresponding height. So first, to figure out how far the football was kicked, we want to find out our two x-intercepts. If you look at our picture, here and here. So the easy x-intercept would probably be this one right here, 50, 0. The other x-intercept is not going to be 0.025 or negative 0.25. It's just going to be 0. 0, comma 0. It is just like this problem right here, negative 1x in front, but instead of it being a negative 1, it is negative 0.025, but it would still make it an intercept of 0, comma 0. So then how far was the football kicked? Well, it's the distance between 0 and 50 would be 50 yards. That's how far horizontally the football was kicked. And then what is the maximum height of the football? Well, we need to find our vertex. The x-coordinate of the vertex will be half the distance, or halfway in between 50 and 0, so 25. And then y equals negative 0.025 times 25 times 25 minus 50. And we type that into the calculator, and this will give us the y value of the vertex. Negative 0.025 times 25 times 25 minus 50. We get 15.625. yards. That is the maximum height of the football being kicked. Now, the last thing we're going to do is we're going to write equations in intercept form from the table. In a table, when y is equal to 0, that means you found your x-intercepts. The x-coordinate of the x-intercept, those will be your p and q values. And remember, the a value is 1/2 the second difference. So if we look at this table here in example number 3, here's one x-intercept, and here's the other one. This is the y-intercept, which we're not concerned with right now. So your two x-intercepts are negative 3, comma 0 and 1, comma 0. Your vertex is going to be when we right in the middle of switching directions. So when we find our first difference, 10 minus 0 is 10. 0 minus 6 is positive 6. Negative 6 minus negative 8 is positive 2. Negative 8 minus negative 6 is negative 2. So we changed. We went from 2 to negative 2. That means this is our vertex. Okay. Negative 6 minus 0 is negative 6, and 0 minus 10 is negative 10. And the second difference, 10 minus 6 is 4. 6 minus 2 is 4. 2 minus negative 2 is 4. 2 minus negative 6 is 4. And negative 6 minus negative 10 is 4. So that means our a value is going to be half of that, or 2. Axis of symmetry is x equals negative 1. Equation y equals half of 4 is 2. And it's going to be x plus 3 times x minus 1, because they should be opposites. Minus 1, positive 1. Plus 3, negative 3. We know that this function, this parabola, is going to open upwards, so we have a minimum at y equals negative 8, the y-coordinate of our vertex. Domain is always negative infinity, comma infinity. Range is going to be negative 8, comma infinity. And then the end behavior, both ends are going to go up. So as x approaches negative infinity, y approaches infinity. And as x approaches infinity, y approaches infinity as well. And we're going to skip this problem because that's going to take us a lot more time to talk about and go through. So we can do that in class. So thank you for watching. Make sure you like this video and subscribe.